Hi everyone. So the question right now that we are taking up is majority element, and the question basically says that we're given an array, and there's a majority element that appears more than a half of the length of the array. So there always exists a majority element. This is the condition given here, and our follow-up says that we have to use solve it using linear time, complexity, and constant space. So to solve this, we're going to use Boyer-Urey's majority voting algorithm here, which basically says, let's say we have people from two different political parties. I mean, three different political parties. And political party people is the majority. One party owns the majority. So even if the other two parties combine up and leave the room, there will at least be one person from the majority party in the room. So this is the entire idea behind the approach behind Moore's majority voting approach algorithm. So here what we do is we have a majority element. So initially we have nums of 0 as the majority element, and then we have the frequency of that as 1. So initially this is how our you know thing works, and in the end we are going to always return the majority element. So yeah, major element, let's rename this. So we'll iterate starting index 1 up until n minus 1. So what we do is we are going to check if my nums of I will be equal to the major element. What happens? We are going to increase the frequency of that particular number. Now, else my num is not equal to the majority element. What we'll do is we'll check if the frequency is 1. If the frequency is 1, we'll simply update the major element as nums of I. And else what we are going to do is, else if this is not the case, we'll simply decrement the frequency. So why we have done this? So let's say we have 3 to 3 right now. So what happens? My major element is 3 and my frequency is 3. Now, next up, what we have is nums of I is 2. Now, 2 is not equal to the major element 3. So now we check if the frequency is 1, right? So frequency of major element is 1. So then what we do is we are going to decrement the frequency of major element. It will become 0. Now, since frequency becomes 0, we are going to update our majority element to the current number. So that is what we have done here. So my current number would be, a major element would be 2 now. And then we would also increase the frequency since we have seen 2 once. So that is the way we have done it here, because frequency is anyways 1. So we are not, decrementing and incrementing it again. So plus and minus 1, cancels out. Else what we are going to do is frequency minus minus. So next up what we have 3. So what happens is it is not equal to the majority element. Now again my majority elements becomes 3. And yeah, so in the end we are going to return the majority element. So this is how the algorithm works. The time complexity is big O of n and the space complexity is big O of 1. So yeah, that was it from my end. Thank you for watching. Bye.